Okay, so the calculation of centripetal acceleration, very straightforward, now that we know how fast. Okay, this is square 3 meters per second, and divide by the 25 centimeter radius of that circle. 25 centimeters, of course, 0.25 meters. And the units are going to naturally, it's kind of magically come out, as they must, in units of acceleration. You're going to get 9 meters squared per second squared divided by 0.25 meters, which is 9 over 0.25, and that's meters squared per second squared times reciprocal meters, because you're dividing by the meters. That's the same as multiplying by reciprocal meters. So that's 36 meters per second squared. How many G's is that? Is that more or less than the acceleration of gravity? Just say more or less. It's more, because acceleration of gravity is about 10 meters per second squared. That's accurate within 2%, so I'm going to just approximate it by 10. You don't have to have 9.8 to get an idea how many G's that is. So is that, well, that's between 3 and 4 G's, right? Okay. And probably somewhat closer to 4 G's, probably about 3 point, well, I can say it's about 3.7 G's, okay? 3.672 or thereabouts, I think. Okay. Now, those people that rode the SpaceX capsule up past the space station, stayed up there for 3 days, 3 amateurs, came back safely, comfortably, and they experienced at least 3 or 4 G's acceleration when that rocket was reached its maximum. When the first stage separated from the rest of it, they got a pretty good jolt. Okay? And they could have been up, you know, the early astronauts were up close to 10 G's. I don't think they do that many now. But yeah, you know, I think SpaceX with civilians without extensive training probably doesn't subject them to 10 G's. Okay? Unless it's necessary, and I don't think it would be with the current rocket technology. They're probably up around 5 or 6. I'm just guessing. Okay, you can go to the telemetry, you know, video of the launch, and if it shows the telemetry, you can see how fast they're going at what time. You can easily estimate the acceleration. How much is their velocity changing every 10 seconds? Okay, so you can get that information. But or how much is their speed changing every 10 seconds? Okay, well, that's kind of interesting. Okay. Another thing that I'll just mention here then is if you're moving around this circle, wherever you are, your acceleration is toward the center. Centripetal. Okay? Centrum means center, and centripetal means toward the center. Okay? It's a centripetal acceleration, giving you this centrifugal force outward. Okay? You know, you're being spun outward. That thing was being spun outward. There's a centripetal force that you need to hold yourself on the circle, which gives rise to a centrifugal force that tends to spin things outward. Okay? Your book will give you a better explanation of that. You want to try to understand that, but that's pretty much it in a nutshell. So you're here, then you're here, then you're here. Now in Calculus 3, we deal with the fact that and maybe to an extent in this course, you also have an acceleration in this direction if you're speeding up, going faster and faster. So you have a tangential acceleration and a centripetal acceleration that gives you a resultant acceleration. Okay, and then, calculus 3, we learn to calculate those things. It's not really difficult. You gotta be able to parameterize the path, though, as I've been telling people. Okay, so I guess we might as well complete the picture. Flies all the way around in a constant velocity, constant omega, constant angular velocity. The picture kind of looks like this. Okay? These are your accelerations. Your velocities, of course, themselves are tangent to the curve. So you're going to see these pictures. Okay, so you need this picture and you need this formula. And ideally, you understand how to derive the formula because it only involves 8th grade geometry and a little bit of 9th grade algebra, okay? But it involves a picture that you probably wouldn't really lay on a bunch of 8th graders. Anybody that's had Algebra 1 and geometry should theoretically be able to do that picture easily. And I believe your book, I know the printed book shows you. I don't navigate the e-book, but it's almost identical to the printed book. And I haven't closely looked at the newest edition, but every edition has done this up through the last edition. Okay. So that equips you to do a fairly good chunk of the homework that'll be due next time.